Hello, this is Mr. Wynn, and today's video will be about solving equations. First, make sure you're able to turn a verbal expression or sentence into an algebraic one. And my hint to you is read carefully. For example, 4 more than triple a number. Well, first it says triple a number, so I know that means 3 times whatever, 3x or 3n, I use 3x. So triple what x is, and then 4 more than that. That means 3x plus 4. Where's the next one? Triple the sum of a number and 4. Well, I'm tripling something, but I'm not tripling the number, I'm tripling the sum. So sum is a pairing word. Sum of a number and 4. So I'm going to use my parentheses here. A number and 4. There's a sum of a number and 4, and triple that. So they're very similar, A and B. That small change made the answer completely different. So make sure you read carefully. You also need to know how to be able to turn an algebraic expression or sentence into a verbal one, the backwards. So here, make sure you use your signs and operations correctly. So I see 6x. That's 6 times x, or to be more precise, that's the product of 6 and x. So the product of 6 and, instead of x, I'll say a number. And the other side is equals 72. You could say equals 72, or you might just say is 72. So that's the same math expression or equation in a sentence form. The bottom's a little harder. The left side is 2 times c. Well, that's just double c. So I'm going to say double a number. Double a number. I could say is or equals to or is the same as. I'll say is the same as. Is the same as c squared. So minus 4. That would be the number squared subtracted by 4, or I could say 4 less than the number squared, same as 4 less than the number squared. Or again, you could say double number is the same as the number squared minus 4. That's fine, you can use your words. Alright, there's some more properties or rules that you need to be able to identify. Again, you must memorize these. Reflexive. A equals A. Example, B plus 12 equals B plus 12. It's the same thing on both sides. It's like your reflection. So reflexive is like your reflection. Nothing changes, exactly the same. Symmetric, you have A equals B, then B equals A. You can flip something around. Right here, the example, you have 18 equals negative 2n plus 4. Well, let's flip it. Negative 2n plus 4 equals 18. That's like saying in the past, if your teacher said, if you have 5 equals x, you can flip it and say x equals 5. That's symmetric property. So that first one becomes or turns into the second one. Transitive, if you have A equals B and B equals C, you have 2 things right away, and then it turns into one thing right here. Notice the B's gone. That middle part canceled out. If I know A is the same as B, B is the same as C, well, I know A is the same as C as well. Substitution. You just plug something in or replace it. Here they just replace 6 plus 1 with 7. I mean, that's really simplifying, but same thing. And then y'all know addition, subtraction, properties of equality. Whatever you do to one side, you do to the other side. If I have A equals B, I could add C to both sides. I could subtract C to both sides. Same for multiplication. I could multiply C to both sides or divide C to both sides. Alright, name the property illustrated by this. Well, 8 plus 9 becomes or stays 8 plus 9. Nothing changed. That's going to be your reflection, reflexive property. Alright, 5 dimes equals 2 quarters. Yeah, becomes 2 quarters equals 5 dimes. If you notice they switch, it's still true. Switching is symmetric. So I think of the letter S in switch and the letter S in symmetric. This next one, 50 pennies equals 5 dimes and 5 dimes equals 2 quarters. Now this is 2 equations. All right, and there's a repeat in the middle, 5 dimes, 5 dimes. Well, it becomes 50 pennies equals 2 quarters. The dimes disappeared. When the middle disappears, that's called transitive property. All right, 6 plus 1x equals 21 becomes 7x equals 21. I use the same example. That's just substitution, although not a good one. Substitution. This last one, 10 equals 10 becomes 10 minus 2 equals 10 minus 2. What changed? I added the minus 2 to both sides. That's just the subtractive property of equality. That's subtraction. I just say subtraction. Subtraction property. All right, be able to identify those. Example 3. Solving for a variable in a formula is just like solving for x, but there are no numbers to combine like terms with. So for example, we have the formula for finding the area of a trapezoid is area equals 1/2 height times parentheses base 1 plus base 2 close parentheses. I need to solve that formula for B2. Well, let's start with our formula. A equals 1/2 h b1 plus b2. Like when I'm solving for x, I need to find the letter. I need to get alone. In this case, I need to get this b2 by itself. Positive b2. All right, I need to move everything else. I need to move the 1/2. I need to move the h. I need to move the b1. Well, we usually work on the outside first. To get rid of that 1/2, I just divide by it. Divide both sides 1/2, or let me do a different thing. If you have a fraction, you're trying to get rid of fractions, I'm going to recommend multiplying both sides by the denominator. I multiply both sides by 2. So really I have 2a equals h times, because these cancel right here, b1 plus b2. And I still need to get b2 by itself. I need to move the h. That's h times all that, so I'm going to divide by h. That cancels. So my left side's 2a over h equals parentheses. I don't need parentheses anymore. b1 plus b2. b2 is almost alone. The last thing I need to move is that b1. They're being added, so the opposite operation is subtraction. Minus b1 minus b1. My final answer is b2 equals 2a over h minus b1. Alright, so it's the exact same formula before. Nothing changed. Just if y'all had the 3 letters from before, you could find the area. If you have the area, the height, and base 1, you can find base 2 using this formula. So people rewrite formulas to what they need all the time. Example 4, be able to solve an equation for x, then plug it in to another equation. So quickly, I'll solve this left one. Distribute 5x plus 15. 2 minus 2x equals 14. Y'all should now do their math by now. I'm not going to say every single step, but combining terms. Subtract 17 to get x by itself. And divide. Alright, that's my x. Now that I know x, I can answer the second part. I'm going to go and put this x over here. So, it says, what is negative 5x minus 3? Well, negative 5, I'm plugging in a negative number, so negative 1 in here, minus 3. Simplifying that, PEMDAS basically, multiply. That's positive 5 minus 3. 5 minus 3 is 2. That's my final answer. So I found x on one side, plugged it into the other side, and got my answer. Alright, I'll leave with this practice problem. Try it. It's like example 4. If you get answer 35, you should be good for the quiz. Again, this is Mr. Wynn. Thank you for watching, and see you in class.